Good afternoon. Now I'm going to take a topic called instruction and instruction sequencing, addressing modes and assembly languages. So this is under module number 1, that is basic structure of computers, machine instructions and programming. So here we need to understand it. If one task is carried out by the computer program consists of sequence of small steps like such as what we can say adding two numbers and testing for a particular condition and reading a character from the keyboard and displaying the result on the display screen, etc. and etc. So we have four types. The computer is capable of performing four types of operations. That is, one is data transfer between the memory and registers, like we can say it is a push, pop, exchange, all those things. And then after this data transfer, we have an input output transfer also, that is we can say call, ret, loop and int. And then this is a major things. And data transfer and input or output transfer, these are the some kind of operations we can see here. And now we'll see how the program is executed. Like initially the address of the first instruction is loaded into PC. Then the processor control circuits use the information in the PC to fetch and execute the instructions one at a time in the order of increasing the address. So this is called the straight line sequencing. Like how we can execute each and every instructions, and each and every instruction is having an opcode. Opcode is nothing but we can say it is an operation code. So each and group of bits is allocated for each and every operation code, so that the different architecture performs on each instructions. So the PC is incremented by 4 to point to the next instruction. And executing the given instruction is a two-phase procedure. One is the fetch phase and then another one is the execute phase. So the processor control circuits use the information in the PC to fetch and execute, and one at a time in the order of increasing address. We can say we can say how it is fetched from the memory location and placed in IR. And execute phase, the content of IR is examined to determine which operation is to be performed. So the specified operation is then performed by the processor. So this is how in fetch phase and execute phase is happening. Here we can see the branching now. So this is of data. This is of a program sequencing and control. In that we have a loop. The loop is a straight line sequence of instructions executed as many times as needed. If you want to retrieve the things again and again, so we can go for the loop operation, and it starts at the location loop and ends at the instruction branch is greater than 0. There is a particular condition we can go for test. And during each phase through this loop, the address of next list entry is determined, and then entry is fetched and added to the or not. First of all, it has to be in the instruction has to be fetched from the memory, and it has been added to the particular register, and then finally stored in the register whichever we have. And register R1 is used as counter to determine the number of times the loop is executed. So how many times the loop either it may be the incrementing phase or the decrementing phase, that many times the register R1 is going for the counting phase. And here the content of location are loaded into the register at the beginning of the program itself. And within a body of loop we can go for the decrement phase, and it just reduces the content of R1 by 1 each time through the loop. So here in this loop we can go for call ret. So that is, if you want to return the value we can go for this, and if you want to nil, we can go for it. And then branch instruction, it loads a new value into the program counter. As a result, the processor fetches and executes the instructions at this new address called the branch target. So now it is a conditional branch instruction. So it just only when the condition is satisfied, then it calls a branch. Okay, if the condition is not satisfied, the PC is incremented in the normal way, and the next instruction in sequential address order is fetched and executed. So normally in fetch and execution, what is happening in this fetch phase, the instruction is fetched from the memory location and placed in the instruction register. And in execute phase, what is happening, the content of the instruction register is examined to determine which operation has to be performed. So now we will see this condition codes now. The processor keep track of information about the result of various operation. So this is accomplished by recording the particular information in individual bits called condition code flags. So these flags are grouped together in a special processor register called the condition code register or statute register. And four commonly used flags called N. N is nothing but if the result is negative, else clear to 0. It has to be set to 1. And z is nothing but 0. If the result is 0, then clear to 0, otherwise it's set to 1. So if it is v, it is overflow, it's set to 1. If arithmetic overflow occurs, otherwise it's clear to 0. And c, carry, it's set to 1 if a carry out result from the operation, otherwise clear to 0. So these are the various flags commonly used in this condition codes. Now we will see the addressing modes. So the different ways in which the location of an operand is specified in an instruction, we can say it is an addressing modes. So in this addressing modes, what is happening? For example, if I am going to store a location into the content of location into the register R0, then I can go. If I am giving a very good example called move a comma b, then I am going to add b comma c. So in first thing, move a comma b, so there is it has to be the content of a is going to store in b. So next I am going to add b comma c. So already in b the result of a is available, so I am going to add it into the c. So now already a operation and b operation is available in the c. Now at last what I am going to do is, again I am moving c to register. So in c what is there? A plus b, and I am going to sum up that, and I am going to move. Already in b a is there, and in c a and b is there, so I am going to move those things to the c register. So now implementation of the variable and constants. So here this is the simplest and common way. These are found in almost every computer program, and in assembly language a variable is represented by allocating a register or memory location to hold its value. So thus the value can be changed as needed using some particular instructions. And here is a register mode. The operand is the content of a register, and the name of the register is given in the instruction, and registers are used as temporary storage locations where the data in a register are accessed. For example, as we told in this previous slide in addressing modes, here an example, move R1 comma R2. So copy content of R1 into the register R2. So now is absolute mode or direct mode. So the operand in a memory location, here it's the address is given explicitly in the instruction. Here is an example, move a location R2. So the copy the content of memory location into the register R2. And immediate mode, so it is explicitly defined. And here is an example, we are using the we are going to place a value 200 in register R0, and clearly this is only used to specify the value of the source operand, not the reachable operand. So now we will see the indirection and pointer. So indirection is nothing but address. So the instruction does not give the operand or its address explicitly. Instead, it provides the information from the memory address of the operand, and that it can be determined, and it just refer the effective address of the operand. So indirect mode. So what is happening in direct mode? It just given explicitly in the instruction. So in indirect mode, what is happening? It just contains the address of an operand, and it is called as pointer, and the E of the operand is a content of register and whose address appears in the instruction. So this is denoted by the curly braces and this sign around the register or in the memory location. Here is an example. Whenever if you are denoted by this sign, and we can easily identify this as an indirect mode. So the operand is in memory, and register R1 gives the effective address of the operand. So this is the instructions which we discussed in previous slides. In addressing modes, what we discussed, the same operations we can see here. And now indexing and arrays. So a different kind of flexibility for accessing the operands, and it is useful in dealing with the list and arrays. And in here we are going to discuss about the index mode. It's nothing but an effective address of operand, and it is generated by adding a constant value to the content of register. For example, I can give the value, the content of A, I am going to move it in the register C. So here is a constant value. If I am going to give A is equal to 10, so the same value is going to be constant till the process. So there are two ways of using the index mode that we will see. One is offset. Offset is given as a constant one thing, and offset is in the index register. When we are talking about the constant thing, it just called the displacement. We can say displacement is nothing but it has address of the memory location and value, and it defines an offset. So here is an offset example. And in index register, what we can say is it just corresponds to the memory address, and there it is memory location. Here it corresponds to the memory address, and it defines the offset to the operand. So this is how the two types. And a special register provided for this purpose, or it may be one of the general purpose register referred as the index register. So by using this index register, we can implement the data whichever we needed at any time. So now normally we cannot the CPU does not take the entire system unit from the this one directly. So it just go to the hard disk and it will take. So here what is happening, it just indicated symbolically as x of array, and where x denotes a constant value and it contained in the instruction. And here is a formula called effective address of the operand, that is EA or AEFF equal to x plus Ri. So either in assembly language program it may be used as, it may be given as the explicit number or a name representing a numerical value. So this is the main mode of this index register. So relative mode. So in this relative mode, the effective address is determined by the index mode. So here is a formula called effective address, that is x plus Ri. So that value, index mode is going to define that value. And here is the program counter, and we can use it is in the place of a general purpose register, and here it is identified by the PC, or which always identify the current execution program in a program, that is called the relative mode. And this mode is used to access the data operands, and or we can say it is an instructions. It is commonly used to specify the target address in the branch instruction. Next, auto increment and auto decrement. Normally in auto increment, what is happening, for example, if I am giving a value called 10, so 10 means auto increment means 11. Auto decrement, if I am going to give a value called 5, so here in 5 its auto decrement means it is obviously it is 4. So like here in auto increment, after accessing each and every operand, the main content of the register is automatically incremented to point to the next item in a list. For example, if I am going to give 8, so that increment is 9, so next value it is going to be automatically it is going to be, it's going to point, and we denote the auto increment mode by putting the specified register in the parenthesis to show the content of register, and it is used as the effective address. So followed by the plus sign, and it indicates these contents are to be incremented after the operand is accessed. So if I am going to use this mode, it is possible to eliminate the increment instructions. For example, if I am giving the instruction called add, I can easily eliminate. And when we're talking about this auto decrement, the content of a register specified in the instructions are decremented, and these contents are then used as the effective address of the operand. Here, so we can access the operands in the direction of the descending address. Thank you.